we'll take a little look at the Capital Industries case study that hopefully some of you had a chance to read and can remember what you read in that particular situation that was presented to you. So what we're going to do first, we're going to take a little look at risk, then we're going to look a little bit at teams, we're going to look at project control, and then we're going to look at how we close a project. What I've done is you've got larger presentations for each of these different classes on your Moodle site. What I have done is I've taken the key things that I want to refer you to in class today, and I've put them all into the one presentation, and that's the one I've sent to you. So it's got a reduced number of slides compared to what's on the Moodle site, but it's going to focus, I think, on the issues that are most important. So up until now, a lot of what we've been talking about, if you can recall, has been all about setting the project up. The last little bit of thought that has to go into things before we set the project up is around risk. So we're going to do a little bit about that today. But then really the project gets started, and the fact that we can sort of go through the last little bits all in one go indicate just how important the setting up of the project is in comparison to actually what you do when you execute it, because it can become somewhat mechanistic in that execution phase, particularly if things are going well. But at the same time, so long as you're keeping good control of it, even if things do go wrong, you're most probably going to be able to respond appropriately and get the project heading where it needs to go. So we're going to talk a little bit about a few topics in this first bit. We're going to talk a little bit about risk management. I'll just briefly touch on resource scheduling, and then I'll tell you a little bit about how we go about reducing project duration. So three things, they're all very much linked together. I'm not going to go through this project, but I put some slides in here for a very current project in the defence area here in the UK. It's a European project, in fact, and it's to produce a new fighter jet. Now, again, as with the other projects we've looked at, like the Big Dig, and when we talked about the Scottish Parliament, and we talked about the rail projects, all of these have quite sorry stories to tell, because if you look at the numbers, again, they're late. The amount of money spent is more than they planned. So all of these things again come together. So when I ask you, why did this happen? It happens because these projects are complicated, because we're at the cutting edge. And if anything else, we look at other defence projects. These are just some from the UK. We could look at any country. We could look at the US. We could look at your country. And I'm sure if we were able to get to the numbers, we would find that with these rather complex cutting edge technology projects, what we're going to find is they're all going to run late and they're all going to run over budget. So some more examples for you there to think about, and that becomes important in one of the questions that I've asked you to consider in the assessment at the end of the module. Now, in these particular project cases, again, there was a review. We have an organisation here in the UK called the Public Accounts Committee. So if public money, government money is being spent on projects and they don't perform well, then there's usually some form of audit, some sort of review that takes place, some sort of evaluation. And this was relating to the Eurofighter. And you can see the quotes on there about not being managed properly, not assessing each phase of the project before they embarked on it, and having a culture of blame. And if you recall right at the very, very beginning, when we did that little case study with that company, the Clark Fawcett company, and we talked about one of the questions there, which was about apportioning blame. And I said, don't do it, because a blame culture can absolutely destroy a project. And that was one of the things that caused problems in this particular case. So this is quite a complicated little graphic. I'll let you look at it in your own time, but this was one of the elements of the report, and you can see that it picked out two particular things, but both of them are about risk management. So assessing the concept risk, assessing the risk of the subsequent phases of the project. Risk management came out very strongly in this particular review and is one of the things that often can be overlooked in projects. Now, when we're looking at projects, you can see on this graph what we've got the two axes, certainty of outcome on the horizontal axis and the level of risk, so the complexity of the project on the vertical axis. Now, as you can imagine, if you have a really high level of risk, a very complex project, the certainty of the outcome becomes much less. So often what we do contractually in those cases is we tend to put in place what we call cost plus contracts. Cost plus contracts mean that you're going to pay a certain amount if you're the person buying, but then if there are complexities that come up, new things that you want to see included, you'll pay on top of that additional money to compensate the person doing the work for that additional work. Now you can imagine that that is really very much an open-ended budget. So a lot of companies prefer not to be part of that particular way of doing business, and certainly increasingly government tries not to. The other end of the spectrum, where you hope the certainty of outcome is going to be pretty clear, and hopefully you've done everything you can to reduce the level of risk and complexity, you can then get to the point where you've got a firm price contract. So absolutely, whatever happens, it's going to be that price. In between, because it's a bit of a spectrum, you've got other alternatives that you can consider on the way. And really, it's up to the person who's placing the contract to decide where they think things should sit in this particular graph. Obviously, when you're considering projects such as the defence ones I was just talking about, the level of risk and complexity is quite high. So in many of those cases, they are cost plus contracts, but usually with other strings attached. By that I mean there are usually other elements that have to be complied with if things are going to prove to be successful. So if we just go back a step and we think, okay, so what is risk? What is risk? Risk is the chance that an undesirable event will occur and the consequences of all its possible outcomes. That's what it says on the slide. The thing is, and that quote from a Greek historian at the top is really true, you're not going to do anything really stunning, really special if you don't take a risk. So risk is something we have to embrace, we have to think about, and we have to consider in our projects. So it leads to uncertainty. Lots of different ways in which uncertainty can manifest itself. You could look at any project management textbook and look at the risk management chapter. You could look at books such as this one, which are purely about risk. And you'll see that there are a whole range of different possibilities for where risk, uncertainty can occur in projects. So the way to handle it, how do we do that? Well, we need to go through 4 steps. We need to identify what the risks are. We have to assess them and think about what their impact might be. And then we need to develop the response to it. And we need to then think about how we can control it. And the important thing is that bottom line. This needs to be done at the planning stage. It can't be done as an afterthought. If you've done all of the setting up of the project and you started the project and suddenly you go, aha, I need to consider risk management, then it's too late in the day. It has to be done up front, go along in parallel with the rest of the project. So if we look at this graph here, what this is showing us, it's got one line is relating to risk and the other line is relating to cost. And the timeline is the horizontal axis. So you can see the chances of risks occurring usually pretty high at the start of the project. And if we manage them well and the project is well defined, they should decrease and diminish as the project goes on. So that's the line that starts high, goes low. Now, if we don't think about them, if we think about trying to rectify a risk before we've done very much work, it's pretty cheap. It doesn't cost us a huge amount of money. But if one of those risks actually manifests itself later on in the project, you can see that the cost to fix it goes up. So we have that other graph that starts low and goes high. So it's in everybody's best interest that what we do is we start with the high risk, with the risks being identified at the beginning, deal with them and try and sort them out while it doesn't cost us much money, and then we'll hopefully have a more successful project and won't spend as much money as we go through. This is just a flow chart to show how that identification through to control process should work, and again you can look at that in your own time. One of the ways in which we present this, certainly in project meetings, is to identify what we have as risks and put them on what we call a risk severity matrix. So what we've got, two axes there, impact along one side, so number 5 is high impact, number 1 low impact, and on the vertical axis we've got likelihood of occurrence. So 1 is it's not very likely to occur, 5 it's very, very likely to occur. So as you can imagine, what's identified there as the red zone in the at the corner there, the top right hand corner, that's, well, we really don't want anything up there because they'd be classified as major risks. What we want is stuff to be as far as we can down in the bottom left hand corner, because that means if it occurs, well, it's not going to have much impact and the chances of it occurring are pretty small anyway. But once we have identified the risks, we can then pop them onto this particular matrix and use it as a visual representation that we can share with the rest of the project team. There are a whole range of different ways in which we can assess the risks. Sometimes it's just done by rules of thumb, so just sort of based on previous experience, or we can be a little bit more scientific about it. And there are a range of risk management frameworks that different companies use. I think really it's again up to the culture and the way in which the company you're working for operates. One of the most common though is FMEA, failure mode effect analysis. And basically what we've got here is we're trying to give the risk a numerical value, which for us as technical people sort of fits quite nicely with the way we like to do things. So we have 3 factors that we multiply together: impact, probability, and detection. And by multiplying those together, we then end up coming up with a risk value. Now the numbers for impact, probability, and detection, they're a 5-point scale. So just as I showed you on the previous graph, you'd have 1, 2, 3, 4, 5, and you would identify 1, 2, 3, 4, 5 for impact, probability, and detection. So you're going to be able to have a number between 111, which would be 1, and 555, which is 125. So if it's 1, it means it's not a bother at all. If it's 125, it's going to be high impact on the project, high probability of it occurring, and it's going to be pretty difficult to detect it. It's just going to come at you. So if you've got that risk value associated with the risks on your matrix, you're then in a position to identify what you can prioritize and what actions you might need to take. So that's just one example. Once we've got all of those though, the next thing to do is to think about what we're going to do with that risk. So we can do a range of different things. We can reduce it, we can transfer it, we can share it, or we can retain it. So just go through those. If we reduce it, it means we're going to take steps to try and make it less bothersome. If we transfer it, we're basically going to give it to someone else. It might be that we pass it on to a subcontractor. If we share it, we're going to work with the subcontractor possibly to do something to try and share that risk. And then the last one, retain it. We're just going to accept that it's there and most probably put a little bit of money by to try and help us deal with it should it occur. So there's different ways in which we can respond, and the ways in which we respond are going to drive the way in which we go about conducting the project. Moving on a little bit then, one of the items that can be a risk is that of resources, and most project managers will most probably at some point in their career have on a project claimed that there were never enough resources, and most probably they may do it on every project they do. Resources are precious, they need to be protected. When you've got them, you need to use them wisely. And if there are constraints with regards to those resources, then you need to understand those. Good thing is that today there are some very complex IT systems to help project managers, and often a lot of the risks associated with resource issues can actually be reduced by running some models through an IT system. The constraints you can encounter can be many. They usually break down into things that are technical, things that are physical, or, as we were just talking about, things that are resource associated. So we're going to focus a little bit on resources. When we're thinking about resources and we're allocating resources to our project, there are some rules that we need to think about. We don't split activities just to allocate our resources in a way we would like to. And once we've allocated a level of resource to an activity, we can't change it until the activity is finished. So these are a couple of rules that we tend to apply in the planning process to make sure we get the resource allocation right. There are two types of project that we tend to think about: those that are time constrained and those that are resource constrained. So if they're time constrained, it's where we might have peaks and troughs in resourcing, and so what we have to do is we have to do work to try and smooth the demand out. So we don't have a representation such as the middle graph in the graphic you've got in front of you, but what we have is we have something more like the one at the bottom. So what we've done there is we've moved some work around to try and make sure that, because we've got to have it done in a period of time, we've used the resources as widely as we possibly can, and it may mean that we need to take on a little bit more resource. If it's resource constrained, it's the other way around. What we may have to do is we may have to lengthen the project to enable us to think about how we can use the resources that we have got available to enable us to complete the project as quickly as we possibly can. Generally, there's no great mathematical solution to that. So again, the software can help us, but it's not always going to come up with what might be deemed the best solution. But we as project managers might decide that we can do some things on top of what we are presented by the software to enable us to move forward in sort of a more productive way, I guess. Thing is, if we're thinking about this idea of splitting, why is it not such a good idea? Well, the graphic on the screen shows you why it's not a good idea. If you start splitting things up, what tends to happen is you start to introduce additional delay, because what you start to do is you have shutdown activity and you have startup activity. And whether that revolves around getting equipment, whether it revolves around people, all it does is lengthen the time the project can take to be completed. So it's really, really important that when you think about splitting things up, that you take into account that you're going to have these additional pieces of work that are going to be associated with it, and make sure that you don't go too far and just end up creating a huge amount of effort and work that's not really necessary. One of the things project managers are always being asked to do is reduce project duration. And in order to do that, we employ something that we call crashing. Okay, so when we're thinking about this, what do we need to think about? Well, you've got to have a sound rationale for being able to crash a project to reduce its duration. You need to think about all the conflicts that might be there. You need to think about what the ultimate outcome of the project is. You need to think about what the alternatives are. Can you outsource some stuff? Is there some sort of incentive you can put in place? Or is there something that you can take out of the specification to help you to get to the point where you've got a more manageable project like you've got available? So, crashing. What are we trying to do? We're trying to shorten the activities, the duration of all of the activities to be an optimum for what we're trying to achieve time-wise. So there are some some things that we need to consider when we're doing that. And typically what we do in order to reduce the amount of additional cost that we incur is we start by shortening the activities with the smallest cost increase per unit of time. Okay, that's really, really important. And what you might see in some projects is that you'll have this cost duration plot, and you'll actually identify what it is that you're going to use as the criteria for your crashing process. Over the next couple of slides, there's an example. Again, I'll let you look at it in your own time. The important thing to remember is, along with the minimal cost increase criterion that you want to use, you typically want to crash activities that are as close to the left-hand side, so the start of the network, as you possibly can, so as they can have an impact at the earliest possible opportunity, and you don't use up lots of slack that you might have later on. So if you start crashing activities too late on and then you have another problem, you really don't have the possibility to recover sometimes from that. The other really, really important thing, and I haven't mentioned it yet, is the activities that you crash must, absolutely must, be on the critical path for the network. Remember, this is the shortest pathway through the network, and if they're not on the critical path, they're going to have absolutely no impact on the duration. So it's really, really important that you have them on the critical path of the project. So there's an example over that slide and that slide that you can take a look at when you get some time. Final thing to say really is that you've got to, at the end of the day, review the logic. Okay, so it's really important that whenever you go through any activity to try and reduce the duration of a project or do something with it that starts to mess with the original plan that you've set in place, then you've got to make sure that the logic is there. If it isn't, then you need to take advice and you need to work with others to try and help you to ensure that you have got a good logic when you move forward. If we're thinking about cost reduction, the things we can do are numerous. Obviously, I've already mentioned a couple of these. We can reduce the scope, we can get the customers to do more, we can outsource, use subcontractors, or we can just brainstorm with the project team to try and get alternative things in place to try and help us achieve the same ultimate goal, but perhaps do it in a slightly different way. So really, really important to think about all those possibilities, because they're all linked into managing the risk. And if you manage your risk and you get it all set up and sorted and you know what your options are as you move forward, if you hit a problem, then you're going to be in much, much better position than if you hadn't thought about it right at the very beginning. Okay, so that's all I want to say about risk management. Some of it you may have come across before, but from a project management perspective, it's most probably one of the key elements of planning the project, and it's the last one really before we move forward into thinking about what happens when we implement the project. So any questions from anybody on risk management, or are you all quite happy with that? No, nobody wants to say anything? Okie dokie, I'll move on then. What I want to do now is I want to take a look at the work breakdown structures that we didn't look at last week. So if you remember, what I'd done is I'd asked you to consider a work breakdown structure for a lab. It didn't matter what the lab was. I'd shown some chemical equipment there, but it could have been any lab. And I got some responses from you. So what I wanted to do was I wanted to take a little look at those responses, and I wanted to ask if the person or one of the people, because I think you work together on them in the different groups, would like to just explain the logic of what they were thinking about when they put the work breakdown structure together. I have to say all of the work breakdown structures that you sent to me were very well presented, and as a project manager, one of the most important things is to make sure that you present the tools that you're going to use to communicate about the project with others as clearly as you possibly can. So it's really important to think about the pictorial representation. So this was the first one. It was for a new lab for testing smartphone antennae. I don't know who it was, but is anybody from this group here who would like to say a few words about what they were thinking when they put this particular work breakdown structure together? Now, if there is somebody, please don't be shy. I'll have to go back through my email and see if I can find a name.
Hello everyone, it's not my work, but I see on the slide that a person who make this VBC structure consider three main parts, and one of them is about design of testing equipment, design for he split for different rooms, different settings that it's supposed to be. So like for testing rooms, it's three types of testing rooms which need to make this laboratory testing, and then after split all design stuff, he goes to building and show what can be main stuff like details like doors, windows, maybe something else, and what's in buildings need for for workers, and to make the like space useful and comfort for them. And then third part is about equipment for testing. It's mean what it's necessary to test smartphone antennas. And if we talk about smartphone antennas, we need to test some properties like GSM, LTE, and for them some equipment is needed. And person shows here that what equipment we need for testing these antennas.
Thank you very much, Hannah. The question then I ask you as a follow-up is, does the structure of this work breakdown structure make sense to you? Does it come across as being logical?
For me, it seems very logical, because the whole process of making a new laboratory is here, and it's logical to split it on these three parts.
Okay. When we were talking about work breakdown structures a couple of weeks ago, we were talking about sometimes the work breakdown structure is produced around tangible deliverable items, and some it's produced around a process, so it can look more process-like in terms of the way in which it's presented. Which of the two of those do you think this one is closest to? Is it more tangible deliverables, hard elements, or is it more built around a process? It doesn't have to be Hannah, it could be anybody.
Mr. Clark, can you repeat your question?
Sorry?
Can you repeat your question?
Can I repeat my question? Okay.
Yeah.
When we were talking about work breakdown structures, we talked about how some work breakdown structures can be presented as though they are based around the different elements of something that will come together to produce something else. And it's very much based around perhaps pieces of equipment or hard, tangible, deliverable elements. Other times we can produce a work breakdown structure that is much more about process. So it's the flow of things when something happens, rather than being specifically about things that you're going to actually produce and build. Now, in this particular instance, which one of those do you think this particular work breakdown structure best represents? Is it more process, or is it more around the hard, tangible elements?
So it's about process. There is equipment for testing, and we should test smartphone antennas, and there is structure for testing this.
I'm sorry, could you say that again? I didn't quite catch it.
I just setting up my microphone. So we see that the processware is equipment for testing, our laboratory for testing smartphone antennas, and the structure illustrated equipment for testing power, safety, and reliability. And there is some bands for testing power, like bands of GSM, LTE, and I think the of don't know about samples that should be for testing.
Okay, let me help this along a little bit. If we focus on design, design is one of those elements that when you see it in a work breakdown structure tends to suggest more of a process type work breakdown structure. Yet the other two elements in it, the building and the equipment for testing, are very much about those hard, tangible elements that I referred to. So what we have here is, to some extent, is a little bit of a mixture of the two types of work breakdown structure, because the design element could actually figure underneath the building and the equipment for testing in its own right. It doesn't necessarily have to be an explicit element on the second layer of the work breakdown structure, because you can think, if you've got the building and the equipment for testing, which when they come together produce the laboratory, there may be, perhaps less so for the equipment for testing because it might just be bought from a supplier, but certainly with regards to different elements of the building, there will be a design phase in it. And the question here really is how helpful it is to pull the design out from where it might figure elsewhere within the work breakdown structure and have it as a different element on the second layer of the work breakdown structure. So in some respects, it depends on how complex the work breakdown structure is. In this particular case, it's not so much of a problem, but in a more complex work breakdown structure, it may be of value to incorporate that design element into the other parts that you identify as the absolute bits that are going to go to make up your laboratory. Hopefully I've explained that okay. Does everybody sort of understand where I'm coming from?
Mr. Clark, if I right understand you, you said that design is a process, and another parts like building and equipment for testing is something which is not a process but part of antennas.
Yeah, what I'm saying is the building and the equipment for testing, they're objects. They're objects that when you bring them together, they can produce the laboratory. The design is almost sort of embedded within those two elements. And if you want to consider it that way, you could consider the aspects of design that need to go into the production of the building or the production of the equipment for testing. You could consider that down at the layers further down, so 3, 4, 5 and below, and you don't necessarily have to have it out there as an explicit item on level 2. That way what you're doing is you're focusing your work breakdown structure on the objects that are going to be produced and that are going to go to make the laboratory, rather than the process of doing something to help to get to that. Okay, so it's a subtlety, but it's an important subtlety to understand, because if you do, then you will be in a position to prepare stronger, clearer work breakdown structures as you move forward. There was a similar, if I move on to the next one, and I don't know if somebody from this group wants to talk about this one, there was a similar approach taken here with the design, building and equipment on the second layer. After that, you had slightly different ideas, so that was fine. The same thing still holds, though. It's the question is whether or not you put that design element on the second layer of the work breakdown structure. With this particular group, I was intrigued if somebody could tell me what they were suggesting here on this second, because you produced 2 work breakdown structures effectively. You had the first one there, which was about getting to the lab, and this one here was a separate work breakdown structure. So anybody from this group want to say a few words about this one? No, everybody's going to be really shy.
Maybe this slide about process, actually not about building and such stuff, about how to do a new application and what part of processing supposed to know and have idea what it contains of.
Yeah, that's good. That's a good way of expressing it, Hannah. This is absolutely a process work breakdown structure. There's really no question about this. If you look at it and you go from left to right, you've got the whole raft of different elements that need to be in place to do what is at the top of the chart, the process of creating new applications. There may be some arguments as to whether or not the order of things going from left to right on the second layer is the best representation. I think it's important, although there is no time or flow element really to a work breakdown structure. You do want to make sure that generally as you go from the left side of the structure to the right hand side of the structure, if possible, you incorporate enough logic in there to make it seem as though it flows quite naturally. I didn't specifically ask for that work breakdown structure, but it was really interesting to see what you'd done there. So thank you very much for that, because that was a really good example of a process one. And then the next one was this one, this work breakdown structure. I don't know if there's anybody from this group who'd like to say anything about this one. Again, it's a very similar way to look at it with the design, build and the equipment. Slightly different representation after that. Interesting though, this was a lemonade factory, I think it was, a lemonade laboratory, which was very interesting. I even got some narrative for this one, so it was interesting to see what the plans were for this particular laboratory. Anybody want to say anything? No, everybody's shy. I think same comments hold as on the first one. What I would have, it was a little bit ambiguous on the third layer down with the boxes at the side, the two that have the dotted lines to them. I think it would be better in a work breakdown structure if they were all incorporated more fully, such that you don't have the potential for misunderstanding. The really important thing about a work breakdown structure is it is a clear picture of the project. And when you start having notes and you put dotted lines to things, it starts to increase the potential for a little bit of misunderstanding. So if that whole of that second layer were incorporated, sorry, the third layer were incorporated into one picture altogether, then I think that will be a strong work breakdown structure. But what this group did as well is on the next slide, they actually started to cost things out, which was neat, because this is where we get to the point where we're using the work breakdown structure for something useful beyond looking at the different elements in a project. So what we had here was we had an example of how we'd allocated amounts of money and then we'd rolled it up to get the overall cost for the overall production of the laboratory, which was great. So there were some good examples there, and thank you very much for the work you did. I enjoyed looking at it, and I think it showed that for the most part you've got the key elements of the work breakdown structure idea. So why not use it in future if you're doing a project? Any questions on any of that before we move on to the next little bit I want you to look at? No? Okay. Can I ask, have you had a look at this particular, it was 2 pages that I sent you. This was the little case study on Capital Industries. It was about a project to develop a bumper for a car. Hopefully you've had a little look at it. There was an example here whereby there's a project engineer and there's a functional manager and then there's an engineer who's doing the work. Can anybody, without really getting too carried away, is there anybody who would like to comment on what they think the key learning point was from that case study? It's not difficult, but it's a really important one to consider as a project manager. So if you were to look at that case study and just identify what was the one key piece of learning that you would take away from reading that, what was it, a page and a half, what would it be?
Okay, and I can comment this story and try to find the main idea. yeah, and as I think, so there are actually three persons: functional manager Frank Allen and Paul Roy. And the story is that mm, uh, Frank and Allen that at first functional manager is going to put a new person into a project and to ask this new person to do the task which is very needed to the company. And because this person is new, he got out of the time and just spent a lot of more time that it was in the plan. And actually maybe the morale, the main idea is that the persons who are managing the project should understand that the other person who is doing the task understood him clearly. I think it is.
Yep, I think you're spot on there. I think it's a very simple little case study, but it projects and shares with us a really important point. And that important point is you've got to make sure that everybody understands what it is the project is seeking to achieve at the very beginning. And then you need to understand whether the people that are associated with the project, that are doing the project, are going to be able to do it as you wish it to be done. In this particular case, what we've got an example here is where it's partly down to the structure of the company and the role that the project engineers play with regards the functional managers. It's a situation where Paul Troy he's the person that's going to be doing the work. He just doesn't understand. He's not understanding what it is that the project engineer Frank Allen wants. He understands it at the top level, but coming from the background that he has, he doesn't actually understand what it is the company are looking for. And so he's thinking in his academic way. And so he's thinking about producing a report at the end, where at the end of the day, that's not what's needed to enable the project to be completed, and for that design, that bumper, to then go into production and become part of what makes the company money. So I think it's really important in looking at this particular little case study to remember that what you specify at the very beginning of the project, you must make sure that everybody that's going to work on the project understands it, and that when you're going through the different stages of the project and you're checking in and seeing how the project's progressing, that you're actually making sure that you reinforce what the message is and that people don't wander away from that ultimate path that you want them to follow. So really, really good learning from a very, very simple little case study. Just as with the Clark Fawcett Company, sometimes the simplest of things are the things that can trip up the project manager, can trip up a company, can end up costing them an awful lot of money if they aren't on top of it. But that's what that particular case study is all about. So thank you very much for that, Igor. That was very, very helpful. Right, got a few more things I just want to share with you as we move to the end of the class. The next thing is really to think a little bit about what goes up into making a project team. If I were to ask you this question, what are the characteristics of a great team and what great teams can you identify? How would you answer that? You've most probably, during your entire university career, you've worked in teams at different points. Some of those teams you look back on and you've gone, gosh, that was a horrible experience. Other times you've looked at them and gone, wow, that was fantastic. We really achieved a lot. So what do you think are the characteristics of a great team? And can you think of any great teams that you're aware of that you think are worth sharing with everybody? Okay, we've got something. We've got somebody saying a great team is united but diverse, which is a really good point to make. They have to be united, so they have to, just like in that little case study we were looking at, everybody has to know where they're going. But you're quite correct, you should have a diversity of skills, because you want to be able to employ a whole range of different skills towards whatever it is you're trying to achieve. And then the second bit of the what someone's written, Ivan, is it's stable but flexible. Stability is important. Yes, stability is important. Oh, it's all right, I've just seen the next one, don't worry. I was going to say Liverpool, but there you go. Stable is good because it means that if you want to try and create that unity, having a stable team, so you haven't got people coming and going, you can actually get people thinking about how they can best work together, and you can build on that, build on that, build on that. But flexible, again, which is really good, and that sort of comes in with the diversity. So you're able to flex as different situations come your way in order to help you to take things forward as a team. So that's some really good points. And of course, CSKA Moscow, definitely a great team. Football teams, sports teams generally are examples of great teams. There are others, sometimes in companies, sometimes, for instance, in research labs, there might be some really great teams there. There are a whole raft of different ways in which you can look, but sport is usually a good example of where you see a great team. And again, they know what they're trying to achieve, so they're united. They've got a range of different skills. Football team, you've got your forwards, you've got your midfielders, you've got your defenders, you've got your goalkeeper. And then hopefully, unless you've got some sort of squad rotation in a football team, in a soccer team, you've most probably got a fairly stable first 11 players, so they're going to figure out how best to work with each other. But you can change the formation slightly and get them to play in different ways depending on who the opposition are. So a football team is a really good example of a great team. Someone else has put, everybody in the team should have a similar interest in the result. Of course, it's really important. It's that idea of a common goal. If everybody has the common goal, then they're all going to be interested in achieving it. And at the end of the day, not only just achieving it, but also hopefully getting some sort of recognition or reward for it as well. Okay, so 7-0 last year with Spartak Moscow. I'm guessing CSKA Moscow beat Spartak Moscow 7-0 last year, which obviously is a very important thing to remember, and I'll have to go and look that up and learn more about it. The next one is motivation and team spirit are important. Yeah, you've got to feel good about what you're doing. So being motivated towards the goal, being motivated to want to work with and support others, and having a really good, strong team spirit, that's important as well. And reliability. Yep, reliability, really, really good, because reliability, you've got to be able to depend on each other. And one of the things that you'll see me say in a second is very much linked into that. So building a team, it can have a range of different characteristics, but the team is only going to become effective if the team leader is a strong and effective team leader as well. So it's very, very important for the team leader to lead by example. So a range of different things you need to think about if you're going to lead by example. But everybody who is a leader of a team has their set of characteristics that they need to convey and share and work with the colleagues in the team on. What do we want from the team? Here's some things that I've put down. You want them to be innovative, but you want them to be stable. So that word stable comes up again. You want them to see the big picture whilst you actually are getting your hands dirty. So they've got to have a strategic view and also a get involved view. You want to encourage individuals to be doing things as part of the team, but you also want to stress that they're all working for the team together. There's this idea of actually being involved and letting people get on with it. So empowerment, that's really important as well. They need to be flexible, but you also need to be firm if they start to stray away from the goals. And then the loyalties need to be in the right place. Okay. Sometimes teams can become a little bit too good and they sort of can drift away from what the organisation's about. So it's important that you think about how you balance what the team's trying to achieve against the organisational loyalties you want from them. And this is a quote from a business guru from the US, and I like this particular quote because what it's telling us is that if we do it well, it's actually not just a small improvement, it's a flipping big improvement if we get our team working well. What I was just saying about spirit and people working together, I think one of the things that's really important is trust. Everybody's got to trust everybody else, and trust becomes what I call the lubricant that helps the team to work effectively. If you trust each other, you're going to achieve more than if you find that you're having to think about what someone else might or might not do in a particular situation. And if you have trust, you get that loyalty and that commitment come through. And if you've got a high performing team, these are from the literature, what the characteristics are of a high performing team. And a lot of those we've just pulled out in that little discussion we've had on the chat. Most of you have most probably seen this before, but teams, when they come together, do go through a sequence of events. We call it the forming, storming, norming, performing model. And basically, when we come together, we get all excited, we're very enthusiastic, but then we start to see, oh, there's a few cracks, it's not quite what I thought. So we go into stage 2, which is the storming. So we might have a few arguments, and then we end up getting to the point where we reach an equilibrium. And when we reach that equilibrium, the norming phase, we're then usually pretty cohesive and we can then get on and do our job. And then the last stage there is when we adjourn the group and move on and move everybody on. There are some characteristics that researchers have found over the years that are considered the best conditions for a team. Not too big, people want to be there are the first two. You have that stability, so they're there from the start to the end. It's something they're part of full-time, not just part-time. That you've got this idea of trust. You don't have dual reporting lines, so that Paul Troy one in the Capital Industries was a little bit problematical, because what you had was you had Paul reporting into his functional manager and also into the project engineer. You have a mixture, a diversity of different functions. You've got a really compelling objective for what it is you're trying to achieve, and people are pretty close to each other. Conflict will occur. That's not a problem. What you want to do is encourage functional conflict rather than dysfunctional conflict. So let people feel free to express themselves, but if it gets disrespectful, then that's when you need to stop it if you're the team leader. But conflict is good because it can get things out into the open that need to be got out, or ideas out that need to be discussed. Over time, teams can drift a little, and it's important that you bring them back onto the task that they're being set out to achieve. So if you're leading the team, you need to be aware of that, and you need to think about how you continue to build that team, but keep it focused. And of course, in the world today, virtual teams are much more the norm. So this is where one of the characteristics of a really strong team becomes a little bit more problematical, because teams are around the world. They're there for a range of different reasons. They're there because we want to tap into the very best expertise. It might be that they're close to the market, whole range of different reasons. But if we communicate well and we have clear protocols for that, then it's often a very, very successful way of doing business. So we've got the project planned, we put the team together, so now we need to get on and do it. And when we get on and do it, we need to then control it, because this quote I think is very, very enlightening. How does a project get 1 year late? 1 day at a time. The minute it starts slipping, you're running the risk of having a problem. So it's really important that you have a good control mechanism in place. Okay, in many organizations, it's not performed well. You need accountability, you need to be in control of the project. The way in which we do that is we set a baseline plan. That's that basic plan that we set up based on our work breakdown structure, based on our Gantt chart. And then what we do is we measure progress and performance as we go through. And then what we do is periodically we measure that performance, and then we compare the plan that we produced initially to the actual progress that we're making. And if it's not right, we're falling behind, then we need to take action. We can do it in a range of different ways. We can use a tracking Gantt chart, which is to some extent a visual representation. What this means is we've got the Gantt chart and we just colour in or put a bar underneath to show the progress of the project, and that's something that's quite commonly done. Another way is to look at the deviations from the norm in terms of time by looking at a control chart, and that's really measuring the time performance. But the way I want to just do a quick example with before we finish is to look at what we call the earned value system, because this brings together the cost and the time. It's based on some calculations. It's based on this idea of what we call budgeted cost of work scheduled. Okay, and that budgeted cost of work scheduled is called the planned value. Okay, so BCWS, it's the baseline, it's the planned value. We then have another term, the earned value, which is the percentage of the work that's been completed multiplied by the original budget that we put in place right at the very beginning. And the earned value is called EV, and the original budget is the budgeted cost of the work performed. So we've got the original budget, we've got the plan, and we've got what we've done, the earned value. Okay, so we also then have this other additional term that's called the actual cost of work performed, the ACWP, and that's actually the money that we spent at that particular point in the project. So we have the budget, we have the plan, we have what we've earned so far in terms of value in the project, and what we've actually spent. That leads us to these two what we call variances. So there's a cost variance, which is, you can see the budgeted cost of work performed minus the actual cost of work performed. And then the schedule variance, which is the difference between the earned value and the baseline, okay, which is the budgeted cost of And what we've got here is we've got a snapshot in time. So this is showing us what the situation looks like at a particular point in time. If we look at the different possibilities, those lines can be in different places, and depending on where they are, it will give us an idea as to how well the project is progressing. If these variances are negative, it means the project is behind, both in terms of schedule and cost. If they're both positive, that's where we really want them to be, because in that particular case, we've got everything moving along on schedule. And then we can sometimes have the situation where one is positive and one is negative. So what will happen in a scenario is you'll get a status report that will give you all the information at a point in time about what's going on in the project. You've got your work breakdown structure to start with for the project, and you've then got your project network that you'll have put together for the project, just as we did last time. You'll have your baseline budget, which will show how your resource is spread out over time. And then you'll have the updated status report that will indicate to you what you have spent at a particular point in time in comparison to what you should have spent. And you'll get an indication also as to how much the project has been completed at a particular point in time. So if you look at this updated status report for this particular point, you can then see that we can calculate a cost variance and a schedule variance, which in this case, they're both positive, which says that the project is on target and it's on budget. So just with some simple addition and subtraction calculations, what you can end up doing is creating a really good numerical value to help you identify how much in control your project is. You can then plot that. You can then share that data in a range of different forms. In this case, it's in a table as well. And then you can incorporate that into the project roll-up if you want to. Sometimes we can present the performance as indices. In this case, it's exactly the same calculations, but then we turn it into an index. So we have something that's greater than 1 or less than 1. If it's greater than 1, it means it's under cost and ahead of schedule. If it's less than 1, it's over cost or behind schedule. The mathematics here is very simple once we've got the data that relates to the project that we're conducting. There are a few other slides after this that indicate some of the other numbers that you can think about, but don't worry about those at this particular point in time. This is about thinking about what the forecasted final cost of the project is going to be. In projects, control issues are inevitable. The changes, they can come from outside, they can come from inside. We've already talked about risk mitigation. So there are a range of different ways in which you can deal with it. In the very worst scenario, what you might have to do is change the baseline. Remember, I said last time, we don't do this easily. This is not something that we want to do. We really want to stay on the baseline and look at the deviation from the original baseline. But if you have to, then that may be where you need to go. And you can see what happens here. When we change the baseline, we get a step change either up or down, depending on what we're trying to do. I'm going to leave it there for today because I'm conscious of the time. There are two additional sections to the notes here. One on project closure and review. Just to summarize what it means is in a project, you need to go through a formal closure process and review what's happened. That way the organisation learns. If you don't do it, you won't get that learning. So what this particular section shows is what the different steps would be in helping to close a project down, and the process you would go through to review it. And the last section is looking at some of the current thinking in project management, particularly around virtual teams, around the importance of considering culture in projects, and what are some of the characteristics as we move forward in terms of thinking about what project management is going to be about in the future. Projects are part of organisations. Whether you want to be a project manager or not, you're going to have some exposure to project management. So hopefully what we've done over the last little while will have given you a bit of a flavour for that, and hopefully you can make good use of it when you go off to the next stage of your career, wherever that may be. What I've done is I've put together a little final assessment, 4 questions, a couple of short written questions and a couple of numerical questions, just for you to show that you've got an understanding of what we've covered during the classes. They're spread around from all over the materials that I've been through with you. If you want to have a go at them and get them to me, I will mark them and I will send them back, and I will pass the marks that you all get to Elena. I've suggested that you have a couple of weeks to do it. I don't think you'll find it particularly difficult, but at least it brings everything to a close. If you've got any questions about it, please feel free to let me know. This will be our last class. I've said if you could get the work to me by April the 30th, that will be very helpful, and then I'll turn them round and I'll get them back to you with some feedback. If you've got any further questions, please let me know. You can always get in touch with me by email. I know you've all got to shoot off for another class now, or you've got other things at 11:30 my time, which is what, 1:30 your time. So I'll say thank you very much for today, and if you've got any questions, I'll hang around for a little while. I hope you found it useful, and hopefully get a chance to meet up with some of you at some point in the future. You're welcome, everyone. You've all got my email address, so if you want to get in touch with me at any time, please feel free to do so. And when I do finally manage to get across to Moscow, I'll get Elena to let you know that I'm coming, and if you want to meet up at all, more than happy to do that. Okay, thanks very much, everyone. If there are no further questions, I'll just wish you the very, very best for the rest of the day, and also good luck with your examinations and what other things you have to do to finish your year of study. I hope you all do really, really well, and I hope if you are going on to a job and a career, the very, very best of luck with that as well.